Hello everyone, welcome to CSE Core Concepts in the series of computer networks. In this video, we are going to discuss about two important protocols of the network layer, that is Internet Control Message Protocol and the Address Resolution Protocol. Let us get started with ICMP, that is an Internet Control Message Protocol. So basically this protocol is used for reporting the errors and management of the queries. So it is a connectionless protocol and it works as a supporting protocol with the IP protocol. So it helps the network devices such as routers for sending the error messages, proper type of an error messages and operation information. So for example, if sometimes we do get an error that the requested service is not available or some particular host is not responding or a router is not responding or you cannot reach the router. So appropriate messages are being handled by this protocol. Now problem is that with the IP protocol, it does not have this type of error reporting or error correcting mechanism. So information has to be communicated via some message. So when a message is sent to an intended recipient, it may be intercepted along the route from the sender. Now the sender thought that the communication has reached the destination if no problem is being reported. So if a middleman reports the mistake, then ICMP help them in notifying the sender about the issue. So if the sender does not get anything, so it does not know what is the problem, it will keep on retransmitting. Let's say a host router or something, some problem is not, there, that is not at all working, right? That router is not at all working. Now the sender will keep on sending packets, wait for its timer to get over and again go on retransmitting because it does not know the situation, it does not know what is the problem. So if proper error messages are being notified to the sender about the issue, it will help them. So fine. So if the message is that I can't reach the destination, or if there is a network congestion, or if the packets are lost, so ICMP protocol will ICMP will send proper feedback about the issue. So these type of feedbacks are very essential for diagnosing, understanding and fixing the problem, making sure that the communication can be adjusted or you can reroute to other routers. So network diagnosis can be done by using two types of commands, very popular command. One is the traceroute command, which is used to know the route between two devices connected over the internet. So if you write traceroute and you can find out and you give the destination address, then you will get a glimpse of all the routers which are being covered in the path. Okay, so this will help to have the network issues. You can find out before transmitting the data, you can find out if the network issues are there or not, every router is active or not. The other type of utility is ping, that is packet internet grouper. So this is a simple kind of a trace route which works as an echo request message. So if you want to see whether your destination host is active or not, so you will simply generate some dummy packets, ping it, and it will come back to you. So you can measure the time taken to reach the destination and come back to you. So that will help you to fix the network problems, whether the network is fine or not, or whether there is some sort of congestion or not. So this is the ICMP header which comes after your IP header. So IP header can be anything, your IP version 4 or version 6 header. And these are the values these are the components of the ICMP header. The first 32-bit of the packet contains three fields. The first is your three fields. See, this is 8-bit, code is 8-bit and checksum is 8-bit. So this is, sorry, 16-bit. So it is 32 bits totally, right? So now what does they contain? So first field is the type field. It is an 8-bit packet for message type. What type of message it is, right? It provides a brief description about what type of message, destination, unreachable. Let's see what are the different types of message. Like if it is type 0, echo reply. There's a type 3, destination unreachable. Type 5, redirect message, echo request, time exceeded, parameter problem. So what type of error has occurred? That is with your type. The next field is the code, which is again an 8-bit. It will give some additional information about the message type. Let's say, for example, if you have a type 3 message which is of type destination unreachable, and now destination can be unreachable because of several reasons, that the host is unreachable, the protocol is unreachable, the port address is unreachable on the destination side. So what among those, that is your detailed description which is given in the code. So if the code is 1, destination host is unreachable. If the code is 2, then the destination protocol is unreachable. If otherwise you can have your destination port unreachable. So little bit of more detailed information. And the third field is the checksum field, which is 16-bit. So checksum is used for what? Controlling of errors. So to check the number of bits, control message, enable to ensure that the complete data is being delivered. Now you can see here, after these 3 fields, you have 2 more fields. One is the extended header, and last one is the data or the payload, which is of variable length, right? So these 32 bits of ICMP header are extended header, which has the work of pointing out the problem in IP message. See, so to point out some extra details, right? So identified by the pointer, because of which the problem has occurred. Why the host is not reachable, why the protocol is not reachable. That is, it gives some sort of more additional descriptive additional information. And the last part is the data or the payload, which is of variable length. So if it is IP version 4, the size will be 576 bytes. And if it is IP version 6, the size will be 1280 bytes. So this is all about a small protocol that it's small but very, very important protocol which works hand in hand with the IP, because if you don't receive proper messages, what is the problem, then diagnosis and troubleshooting becomes very, very difficult. Next, we move on to another important protocol, that is ARP, which is called as Address Resolution Protocol. So in a network protocol used to determine the MAC address. What is a MAC address? See, every device has a physical address, right, on your system. Every device, your laptop, your computer, whichever is connected to the network has a physical number, right? That address is called as the MAC address. But when we want to connect to a particular host, we always convey by the IP address. IP address is fine because it is a logical address. You can know how many networks are, which network it belongs to, how many hosts it has, everything is fine. But actually the data has to be delivered to that system, right? So it has to go via the MAC address. So when one device wants to communicate with another device in a LAN, local area network, the ARP protocol is used. So IP address is used to communicate with any device at the application layer, right? But actually when you want to communicate at the physical layer, okay, there you will require the MAC address. IP address is logical address used in the application layer. So when data is sent to the local host, the data travels between the networks via the IP address from one router to another. But to reach that host in the local area network, it needs the MAC address of that host, because in local area network, all computers are attached by the Ethernet. So in this situation, the address resolution protocol plays an important role. Now there are 3 types of address resolution protocol. One is, it is used through the client computer. If you want to know the MAC address of the server, generally server sends the message, so server wants to know the MAC address of the client. But if the client wants to know the MAC address of the server, then it is called as the reverse ARP. If the ARP is very, very busy, and if you want to know whether your host is in this, there are multiple networks, 5-6 networks. Now if you want to send the address to somebody, let's say for example, if you are going to some office, right, passport office or PAN card, whatever, any important office. Now sometimes the clerical work is too heavy for them to do, so many people are coming, so they are very, very busy with the clerical work. Now Suppose you went to the office, you do not know if what this work has to be done in which number counter, right? So instead of asking the clerk who is already busy with some other work, they give this work to the security guard or any other peon. They will tell that you work on our behalf. You tell the person that you go to this counter. So same thing is done in proxy. Proxy means what? On behalf of something. So on behalf of the ARP network, okay, there are proxy ARPs. Proxy ARPs, when any packet comes, it can just tell based on the network address where this network is. Understood? Is this is the network or you have to go to some other network? So that is the work of the proxy server. So responding of queries of others networks. Then third is the inverse ARP. Generally, we want to find out based on the IP address, we find out the MAC address. But here in inverse ARP, we use the MAC address to find the IP address. So this is called as the inverse ARP. Now, what happens? How actually the ARP works? Let us see. So when a sender wants to communicate with the receiver, let's say there is a sender and he wants to communicate with the receiver. So the sender will first check its ARP cache. So I hope you know about what is a cache memory. So to retrieve faster, we have a cache memory where the details are kept. So first the sender will check in the ARP cache because it wants to retrieve its MAC address. Sender will check whether the receiver's MAC address is already present in the cache or not. So if it is a frequent receiver, then the MAC address will be stored in the cache. Otherwise, it will have to retrieve. It is not there. Let's say if it is already present, very well, it will simply get the address from the ARP cache and send to the receiver using that MAC address. But the problem is that if the receiver's MAC address is not present in the ARP, then ARP will have to find out the receiver's IP address. So in that case, the sender device will prepare a proper message format that is called as ARP request message. These type of message are called as ARP request message, which are being sent to whom? They are being sent to the ARP database. We will come to it. Now see what this request message contains. The request message contains the MAC address of the sender, the IP address of the sender, and the IP address of the receiver. It does not contain the MAC address of the receiver because that is what you are searching, right? Then senders device will do what? Broadcast this request message in the LAN. It will not send to particular. It will broadcast this message to the LAN. Because this broadcast message, every device connected to the LAN is receiving it. Everybody will receive this message. Now all device will check their own IP address if it matches with that message request. Okay, those whose does not match, they will simply ignore the message and drop the message. And those device whose IP address matches with that request message IP address, it will prepare a ARP reply message. And this reply message is a unicast message. The sender request message was broadcast because you are broadcasting it to all the devices and finding out the IP, right? But while whoever's IP address is there, he will send only to the sender, right? So that time the message is a unicast message because it is only sent to the sender. So in the reply message, what are the contents? The contents are the sender's IP address, sender's MAC address, receiver's MAC address, and IP address. So besides this message, the receiver also sends IP address and the MAC address. So as soon as the sender device receives this reply message, whenever the sender receives this reply message, it will update the cache with the new information, that is the MAC address. So that next time when it wants to send a message to the same receiver, it can easily collect its IP address, find its IP address from the cache instead of again sending a message and getting reply. So this is the working of ARP, that is Address Resolution Protocol. I hope you understood this. In case you understood and enjoyed the video, please do like the video and don't forget to share and subscribe to CSC Core Concepts. Thank you.